Good morning, everyone. My name is Aditi, and today I'll be presenting on testing mechanisms across the life cycle. Software failures can cause major issues from financial losses to security breaches. Think about a time when an app you used is crashed or had a bug. Annoying, right? So that's why software testing is crucial. It ensures application work properly from their reach before they reach the users. Throughout this presentation, we will explore different testing mechanisms, tools, and challenges in the software development lifecycle. So, has anyone ever faced an issue with an app where a website that doesn't work or as expected? Great. Let's begin this with the basics of the software testing. Let's start about what is software testing. It's a process of evaluating a system or application to find bugs before it releases. Why it is important? If a company releases software without testing, users might experience crashes, errors, or security risks. So let us talk about a case study. In 2014, a major banking app in India had a bug, but it double charged customers for transactions. Without proper testing, this issue caused thousands of complaints and financial losses. This is why testing is essential. It ensures that apps, websites, and software are reliable and secure. So, can you think of an app or a website which you use daily that has gone through a rigorous testing? For example, a bank or e commerce or social media, any kind of platform? Software testing life cycle. The testing follows a structured life cycle like STLC, which includes several phases. First one is requirement analysis, second is test planning, third is test case design, fourth is test execution, and fifth is test closure. So let us learn about each one. Requirement analysis, which needs to be tested, for example, the interface, features, and the payment gateway, etc. Planning, in this we learn about we do the strategy, tools, and resources needed. For the test case design, we follow the steps and expected results should be done. Test execution, running tests and logging defects should be checked. Text closure, reporting and analysis. For example, imagine an e-commerce website like Amazon. Before launching a feature like buy now, the testers will check if clicking buy now adds the product to the cart, ensures the payment goes through successfully, and confirms users receive a confirmation mail. So, have you ever faced an issue where you clicked a button but nothing happened? Types of software testing. There are different types of testing, each with a specific purpose. Functional testing, non functional testing, manual testing, and automated testing. In functional testing, it ensures features works, for example, login page, checkout page, etc. In the non functional testing, it focuses on performance, security, and the usability. In the manual testing is done by the human testers, and the automated testing is the use of tools for the efficiency. For example, a banking app must go through functional testing to go check if the users can send money correctly. It must also pass a non-functional testing to ensure it loads within 2 seconds during the peak hours. So now let us talk about functional testing, the types of functional testing, and with a real world example. So in the types of functional testing, it consists of unit testing, integration testing, system testing, and user acceptance testing. In unit testing, it tests small components of the code, whereas in the integration testing, it checks if the module interact correctly. In the system testing, it tests the full application. And in the user acceptance testing, it ensures real users approve the system. And the real world example goes like before launching UPI system payment in India, developers performed rigorous testing to ensure transactions processed within seconds, validate that money was debited and credited correctly, ensure security vulnerabilities to prevent frauds. Sanity testing. Sanity testing is a quick surface level check to ensure that a particular function or a feature of the software works correctly after a small change or bug fixes. It verifies that the recent updates haven't broken critical functionalities and that the software is stable for further testing. Its process is a stable build undergoes sanity testing, smoke testing, a preliminary test that checks basic functionalities of software after a new build or update. Its purpose is to ensure that the software is stable enough for further detailed testing. When performed right after new builds or updates are deployed, the process is a new build is created, smoking testing is performed. If it passes, the build proceeds to further testing, but if it fails, the build is sent to further fixing. For example, checking whether login and the home page load correctly deepen tested. Different testing approaches. We have three main approaches: black box testing, white box testing, and gray box testing. In black box testing, the testers focuses on inputs and the outputs, whereas in the white box testing, testers examine the internal code. And in the gray box testing, a mix of both. For example, when a user enters the wrong password on a website, the tester checks if the system correctly displays an invalid password error. Acceptance testing. It is the final phase of the software testing that ensures that the system meets business requirements and is ready for the deployment. There are two types: alpha testing and the beta testing. In alpha testing, it conducts internally by the development team to detect bugs before releasing it to the users. In beta testing, it is performed by a selected group of the real users to gather feedback and identify the issues. The process is, if the software passes acceptance testing, it is ready for the customers, but if it fails, it needs further improvements. For example, a company testing its mobile app with real users before launching it to the public. Unit testing. Unit testing is a process where individual components or functions of the software are tested to ensure that they work correctly. The purpose is to ensure that each part of the code functions as expected. It helps identifies and to fix bugs early in the deployment. Its example is testing a function that calculates the total price in a shopping cart to verify its provided accurate results. Developers write and run unit tests before integrating the code into the complete system. Integration testing. Integration testing is done after the unit testing. In the integration testing, it evaluates the interaction between the different software modules or components. The purpose is to ensure that the combined parts work together as expected. It identifies the issues in the data flow and communication between the modules. When it is performed, it is conducted after unit testing and before the system testing to verify proper module interaction. Big Bang integration testing. All software modules are integrated and tested at once without any incremental steps. Its advantages are simple approach, quick testing after full integration. Its disadvantages are hard to isolate defects, difficulty to identify which module causes issues. Why it is used? It is best for the small systems where all components are ready at once. Incremental integration testing. The modules are integrated and tested one at a time, following either a top-down or a bottom-up approach. Why it is used? It is best used for the larger systems, ensuring better defect isolation. Top-down integration testing. The testing starts from higher level modules and progresses downwards. In here, stubs are used where it acts as a mock components which stimulate the lower modules. When it is used, it is best used when high level functionality needs verification first. Bottom up integration testing. It starts by testing the lowest level modules first and gradually integrating and testing high level modules. It has drivers, which are known as the dummy modules, are used to stimulate the behavior of higher level modules that are not yet integrated. The testing continues upward until all modules are integrated and tested. When to use? Best when low level modules are complex and need to verification first. Non-functional testing. In non-functional testing, it focuses on the quality of the software. It includes usability, performance, and the security. In usability, it ensures it's user-friendly, and in performance, it tests speed and the responses, and in security, it finds the vulnerabilities. For example, during an IPL ticket booking, websites handle thousands of users at once. Without performance testing, the site might crash during the peak hours. So let us talk about manual testing versus automated testing. In manual testing, as the word represents, manual, which is done by the human, where it is useful for user experience testing. Whereas in automated testing, it uses tools like Selenium, JUnit, and Postman. So let us take an example. If a Netflix runs automated testing daily to ensure smooth streaming, if they relied on manual testing, it would take weeks to test all the features. So in based on the current technology, we use both manual and automated testing, but using automated testing take a few period of time. Testing tools. Testing tools help automate and improve the accuracy of the software testing, saving time and effort. Some commonly used tools include Selenium, JUnit, Postman, Cucumber, and Citrus. In Selenium, it is used for web testing, which automates testing for websites by stimulating user interactions like clicks and form submissions. For example, it is used to test login pages and online shopping carts. In JUnit, it is used for testing Java. It ensures individual components of Java programs work correctly. For example, testing a shopping app's add to cart function. And in Postman, it is used for API testing. It checks how different software components communicate using APIs. For example, testing if a weather app fetches real time data correctly. In Cucumber, it is a behavior driven testing. It uses human readable test cases, making collaboration easy. For example, writing test cases in plain English instead of code. In Citrus, it is an integrational testing. It ensures different systems, databases, and APIs work together. For example, testing if a banking app correctly processes transactions and updates account balances. So let us understand why these tools are important. It helps in fast testing where it automates repetitive tasks. It helps in more accuracy, which reduces human errors and is cost effective, detects bug easily, and preventing expensive fixes later. System integration testing. System integration testing ensures that different software modules, API, and external systems work together correctly. For example, a shopping website integrates multiple systems. The cart system stores selected items. The payment gateway processes transaction. The order management system tracks deliveries. Without proper integration testing, the cart might not update and after the payment, or payments could be deducted without confirming the order. So, why it is important? It identifies data flow issues easily, ensures seamless user experience across different modules. User testing and platform testing. These tests ensure that software is usable and runs smoothly on different devices and operating systems. User testing. Real users test the software before final release to check if it meets the expectations. For example, a food delivery app is tested by the users to ensure order is placed and the tracking and the payment works as expected. In platform testing, it verifies software compatibility across different operating systems. For example, in Windows, Mac, Android, iOS, and the screen sizes. For example, Instagram ensures its app looks and the functions the same across Android, iPad, and tablets. Why it is important? It prevents app crashes and UI issues on different devices. It ensures users get a consistent experience across the platforms.
Why testing is important? Testing is crucial because it prevents failures and user complaints. Imagine an airline booking system crashing. Tickets could be lost, causing chores. It also saves time and money since fixing bugs early is much cheaper than fixing them in production. Testing ensures smooth performance, making the software work under the all conditions. It also ensures and enhances security by detecting vulnerabilities before the attackers can exploit them. Finally, it improves user experience, ensuring reliability and seamless functionality. In short, testing guarantees quality, security, and efficiency, making it an essential part of software development.
Few challenges in testing. The common challenges are tight deadlines, changing requirements, device compatibility. So in 2018, a major airlines booking system crashed due to a untested update leading to cancelled flights and losses. So what do you think happens when the testing is skipped?